Okay, let's jump right in with a question that could literally be worth 5 marks on your CUET exam. Why does phenol play nice with a strong base like NaOH, but completely ignore a weak one like sodium bicarbonate? Understanding this isn't just about memorizing facts. It's a huge concept that comes up all the time. Stick with me through this explainer, and I promise you'll have this down cold. In the next few minutes, we're going to break down everything you absolutely need to know about phenols to crush this section in your CUE exam. We're talking pure exam-focused content, zero fluff. So let's get right into it. So here's our game plan for today. First, we'll see why this chapter is such a massive score booster. Then, we'll dig into the secret of phenol's acidity. After that, we'll tackle the most important chemical reactions, test your knowledge with some real exam-style questions, and finally, I'll walk you through the common mistakes to avoid so you don't lose any easy marks. Let's dive into Section 1. All right, Section 1, let's talk strategy. Why are we dedicating a whole session just to phenols? Well, it's simple because this topic is one of the most predictable and high-scoring areas in your entire chemistry syllabus. I mean, just look at this number. You can expect 3 to 5 direct questions just from this one topic. That is a huge chunk of your chemistry score just waiting for you. And trust me, these are marks that are totally within your reach if you just focus on the right things. And that's exactly what we're about to do. And here they are, the exact types of questions the examiners love to ask. They're obsessed with acid strength comparisons, the reason for phenol's acidity, that classic NaOH versus sodium bicarbonate question, what the major product in nitration is, and of course, the ortho/para directing effect. If you can nail these 5 areas, you've pretty much conquered this chapter for the exam. Okay, let's move on to the core concepts to really answer those why questions. And not just memorize. You've got to understand the secret behind phenol's behavior, and it all boils down to its structure and one single powerful idea. So what is phenol? It's really simple. You've got an OH group directly attached to a benzene ring. But its special power, and you have to burn this word into your brain, is resonance. The way the oxygen's lone pair of electrons gets involved with a benzene ring, well, that's the key to everything else we're going to talk about. This slide right here answers a classic CUET question. Why is phenol so much more acidic than a regular alcohol? Well, when phenol loses its proton, it forms the phenoxide ion. This ion is super stable because that negative charge isn't stuck on the oxygen. It gets spread out across the entire benzene ring through resonance. Alcohol, on the other hand, it forms an alkoxide ion, and that negative charge is just stuck on the oxygen. It's got nowhere to go. And here's the golden rule. A more stable conjugate base always comes from a stronger acid. It's not simple. And this brings us right back to the question from the very beginning. Phenol is acidic, sure, but how acidic is it? It's strong enough to react with a powerhouse base like sodium hydroxide, but, and this is the key detail for the exam, it is a weaker acid than carbonic acid. And because of that, it's not strong enough to kick carbonic acid out of its salt. That's why it doesn't react with sodium bicarbonate. Just remember this simple rule, a weaker acid can never displace a stronger acid. Okay, now that we've locked in the core theory, let's get into the practical side of things, the reactions of phenol that are absolute favorites for the exam. We'll quickly look at how it's made, and then jump into the key substitution reactions that you are almost guaranteed to see on your paper. So, there are 4 main ways to cook up some phenol you should know about. The Dow's process and using diazonium salts, for sure. But the one you absolutely cannot, under any circumstances, forget is the Cumene process. Why? Because it's the most important industrial method, and examiners love to ask about it. Pro tip, remember that its major byproduct is acetone. That's a detail that can definitely show up. Now, when it comes to its reactions, this quote right here is the golden rule you need to live by. That OH group isn't just sitting there. It's a powerful activating group. Through its positive resonance effect, it shoves electron density into the benzene ring, making the ortho and para positions super electron-rich. It's basically putting up giant neon signs that say, "Attack here," for any incoming electrophiles. So here are the top 3 reactions you have to know. First, if you hit it with concentrated nitric acid, that ring is so activated that it gets nitrated 3 times to form picric acid. Second, with bromine water, the reaction is crazy fast, and you get this instant white precipitate of 2,4,6-tribromophenol. And third, for sulfonation, just remember that temperature is the boss. Low temp gives you the ortho product, and high temp gives you the para product. All right, we've gone through the key concepts and the big reactions. Now it's time to put that knowledge to the test. Let's see what's actually sticking. First, I'll give you a simple strategy, and then we're going to hit some practice questions that look just like the ones on the real CUET exam.
Here it is, your 4-step mental checklist for any phenol question. Go ahead and write this down. First, always think resonance. That explains its acidity. Second, compare the acidity. Is it reacting with a strong or weak base? Third, remember the ortho-para directing effect. And finally, put it all together to predict the major product. Use this simple strategy every single time.
Okay, first question up. Take a look. What is the major product when phenol is treated with concentrated nitric acid? Go ahead and pause the explainer right now, figure it out, and then hit play.
The correct answer is C, 2,4,6-trinitrophenol, also known as picric acid. So why not just one nitro group? Because the key word in the question was concentrated nitric acid. That OH group is such a powerful activator that all 3 of the open ortho and para spots get nitrated. Boom, try substitution.
Let's try another one. This one tests a core concept we talked about. Phenol won't react with sodium bicarbonate because it's a weaker acid than what? Pause the explainer and lock in your answer.
And the answer is B, carbonic acid. This is that fundamental rule of chemistry right in front of you. A weaker acid just can't kick a stronger acid out of its salt. Since phenol is weaker than carbonic acid, it just can't make that reaction happen. This is a concept they love to test.
We're almost there. Now, I need you to listen very closely because this is one of the most important sections. We're going to go over the common traps and silly mistakes that students always fall into, so you can sidestep them on exam day.
Okay, listen up. These are the 5 errors that can cost you easy marks. Number 1, messing up the acidity order. Remember, it's more acidic than alcohol, but weaker than carboxylic acid. 2, confusing the products of dilute versus concentrated nitric acid. 3, forgetting the bromine water test gives that classic white precipitate. 4, ignoring that temperature controls the product in sulfonation. And 5, not remembering that the Cumene process is the main industrial method. Avoid these, and you are way ahead of the game. All right, everybody, get your phones ready. This slide is your ultimate revision tool. It takes this entire chapter and boils it down into 6 essential points. I want you to take a screenshot of this right now. Save it for your last-minute revision right before the exam. This is pure, high-yield info that will save you a ton of time. So we've covered the theory, the key reactions, the common traps, the whole shebang. Now the last question is for you. How did you do on those practice questions? Be honest, drop your score in the comments below. Learning from our mistakes is how we get better. If you are serious about cracking CUET, you are in the right place. Now go and master this topic.